Okay, lesson 1.1, and it says can change occur at an instant. In reality, I would rather this be titled Introduction to Calculus. And it's just a classic example of how to introduce calculus with the function that I would reference back to the warm-up that we just did. And so what is the slope of the line tangent to the graph of f of x equals x squared at the point 1, 1? So here is the graph of a quadratic equation. Okay, so I hope that you had a really good algebra 2 teacher that taught you about parent functions here. Okay, most of you guys had me already, and it was me who was teaching you, so it's kind of a joke here. But f of x equals x squared is a quadratic equation, and in the warm-up I said that the only function that has a constant rate of change would be a line, because a line has no matter where you're at any point, the rate of change is the same as at any other point on the graph, because it's a straight line. But for curves, it is changing all the time. The rate of change. So like for example here, and I was talking about in the warm-up, and I said that all I know here is that the tangent line at this point is negative, and all I know here that the slope at this point is 0, and all I know that the tangent line here at this point is positive. But what exactly is the rate of change at each one of these points? That's the big problem. So in this one, it says what's the slope of the tangent line for this quadratic at the point 1, 1. This is the point 1, 1. So it's just asking about what is the slope of the tangent line. So here's the tangent line here. This would be the tangent line. Even more, not just answering, which we will try to figure out what the slope of the tangent line is. If we wanted to even figure out what is the equation of this line here, what's the equation of this line? We already do have a point. The point given is 1, 1, x1, y1. So we could just go y minus equals the point slope formula that we did. We got this 1 here, and this is x, and then we got minus 1 here. The problem is finding what is the slope of this. What is the slope? That's the big problem. Everything else is okay. So how can we figure out what the slope is? And here's where how calculus was developed, is that we can approximate what the slope is by having 2 points on the graph. So this is called secant lines. Say for example, through the point, say -1, +1, and another point on the graph, I could choose any other point and say 0, 0 here. This is called a secant line. This is called a secant line. And it approximates what is the slope for any point including -1, 1, and 0, 0. And it's just the average of all the rates of change between -1 and 0 of the curve. But it's not the exact rate of change at the point, at any one of those points for right now. This might be equal to one of those points, but let's stop there. The rate of change might be equal to one of them. That's for future talk here. So now what we could do here is apply that understanding that we can have 2 points be the secant line. Say 2 and this is 4. So we got these this secant line here is an approximation of the actual rate of change here, where I had said that the actual slope at this point, which would be the instantaneous rate of change, which would be the tangent line to the curve. And what we're going to do is we're going to get this second point get closer and closer to the first point. And when we get the first point, the second point get closer and closer and closer and closer and closer to the 1 point, the more we're approximating exactly or getting to what the rate of change here is. That is the big idea here. Okay, so how are we going to do this? All right, so we can make a table of values. And the secant line is called, the slope of the secant line is equal to, okay? So if I call this point 1 B, let's say point 1, let's label it as a variable A, and we can label any other variable here B, okay? So you got A, and then we're gonna have f of A, be this, which A is 1, f of 1. And we can have any other point here. I could use B is 2, and then go to f of 2 is 4, which makes sense, no? Because if you plug it in here, 2 squared is 4. Okay, so the secant formula, the formula is really the slope formula, which what is the slope formula? Do you guys remember? What was the slope formula? X2 minus X1, Y2 minus Y1, which now is basically algebra 1 written in function form, where now X2 becomes B and X1 becomes A. B minus A, okay? They're just variables. They represent, X2 represents B, X1 represents A. Then you got f of B minus f of A. And this is called the secant formula. Okay, so we got this, okay? We've gone through this. Hopefully it's okay so far. What we're gonna do is we're gonna make the second point, we're gonna have to choose intervals. This is gonna be stuck. Point 1, 1 will be stuck. The second point will approach the first point. So we can have 2 points and find a slope of it. Okay, so let's choose 1 and 1.5. So if we go here 1 and then 1.5 is here, then we can get what this is here. And we would have 2 points. So for this interval, this would be A, this would be B, and we just plug it into the secant formula to find an approximation of that rate of change. So let's go ahead and do it. So M secant for this approximation will be, where, look at the formula, B minus A, so it'll be 1.5 minus 1, and f of 1.5 minus f of 1. So 1.5 minus 1 is 0.5. F of 1.5, plug it into the equation given, the quadratic. 1.5 squared is 2.25. 2.25. You can get a calculator and verify that with me. Minus, plug in f of 1. 1 squared is 1. So we got 1. So you got 2.25 minus 1 is 1.25. And that is being divided by 0.5. So what is 1.25 divided by 0.5? Get a calculator for that, and you will verify that that is going to be 2.5. All right. So we got the slope of this secant line that we have here, this one, which is not the tangent one, is the secant one, is going to be 2.5. It's an approximation, very close, but it's not it. let's get that point closer. So get this yellow point, get it a little closer, maybe here. And then let's find what would be that slope. Actually, get it even closer, 1.1. Let's do it. Let's get it as close as possible, maybe here. And that's even going to be closer to what the slope is here. All right? So all you're going to do is plug it into the formula. You got now, this is A, this is B, and we're trying to get closer and closer to it. And this is f of 1.1 minus f of 1. You can just put this in a calculator and solve it and find the answer to this. We see that now this slope is 2.1. It's a better approximation of what it really is. So the slope of this secant line is getting closer and closer to the tangent line. What if we get this point even closer, which I can't even draw the point here, which is not even, it should be just so close to each other that it actually almost gives you the slope of that tangent line. And we go back to just using the equation given here, just plug it in there, and you get m secant will be, now this is A, this is B, you're going to go 1.01 minus 1, and then f of 1.01 minus f of 1. Put all that in a calculator, and then you're going to get 2.01. As you notice here is that the slope is getting closer and closer to some number. It's getting closer and closer to a number. So if you think about money, $2.50, and you got $2.10, you got $2 and a penny, $2, and it's getting closer to maybe $2. Let's get it even closer between A and B. So you got this A is 1, but the B is even super close to it. The limit as it approaches 1 is called. The second point approaches 1. We put it into the formula again. You get 2.001. And if I really wanted to, why didn't I just start here, and why did I have to go like that? We go A and B. And what if I would have done keep the first one 1 and do the second one be 1.000001, and it will definitely probably get you to the answer being 2. If you really want to, you can go ahead and verify that, but you will get to 2. That eventually you will just say that the slope here is 2, and then you have found the equation of the line tangent to this curve being y minus x, value of the point is 1, equals x minus the y value is 1, and we have found the slope, which was our big problem that we had come up now that the slope is 2, and we are done. Okay, let's move on. How can we apply this to, okay, we'll do it in a different lesson for that one.